Hello and welcome to video number 1 in the Introduction to LogicWorks for Windows series. LogicWorks is a schematic capture and digital simulation system, and it's ideally suited for teaching digital logic. It's used by universities and colleges all around the world. Now, to start up LogicWorks, it really depends on the system that you're using. If you're using Windows 8, then basically go up to the Charms menu and search and type in LogicWorks. And then you just double click on the result. Now, another way is to install a link to LogicWorks down on the taskbar like I've done here. And if you are going to be using LogicWorks a lot, I would highly recommend doing that. If you're on Windows 7, you can also add an entry to the taskbar, or you can go over and launch it from the Start menu in the lower left-hand corner. Now, this is a Windows 8 box, so there's no Start menu, or not at least a real one, which I really miss. In any case, let's get going by double-clicking on LogicWorks. Up it pops. There we go. Now I'll move things around a little bit. I've turned the resolution of my screen down so that I can make a video that will look good up on YouTube. So generally I would have a bit more real estate than there is here, so I'll just change the size of things a little bit. Now we'll go over, and what I want to do is do a new to create a new drawing document, a circuit drawing document. So there's sort of three areas in the screen here. There's the document that we just opened, which is blank. There's a timing window down here where timing waveforms appear. And over here is the parts palette, where all the parts for the currently loaded libraries appear. Now, the best way to learn about LogicWorks is just to start playing with it. So I'll build a simple circuit to show you a few of the features. So one thing I can do to find a part is just go over to the filter area here. In this particular example, I need a 74164. So I just type that in, and up it pops here. Now I can either just click and drag like that and place it on the part like that. Or if I am actually going to be placing multiple copies of that device, then I would double click on it, and the cursor disappears, and the outline of the part appears. And you can drop them down as many times as you like. But in this particular case, I only need one. So I need to now terminate the placement mode, and I do that by hitting the space bar. You could use the escape key, but I find the space bar a lot easier. Okay, now I also need an exclusive NOR gate for this little demo. So I'll go over here, and this time I'll find it by going to a specific library. If I go to Simulation Gates here and pick it, then all the parts for that library appear down here. And they're alphabetical, so I know that exclusive NOR is at the end. And I can get my 2-input exclusive NOR gate here. So I double click on it, and then I just move it over and bump it up against the pins and click. And you probably didn't see it on the video, but the two pins here flashed red briefly just to indicate that the connection was made. Again, I terminated the device placement mode by hitting the space bar. Now I don't quite like the gate being that close, so I can just click on it and move to the right, and I've now moved the device. What's nice about LogicWorks is it tries to stay modeless as much as possible. It tries to figure out sort of what you're doing or what you want to do by the context. And in that particular case, you were clicking and dragging, so it assumed you wanted to move the part. Now I'm going to actually create a signal. And again, it's going to figure that out because we're going to go to the end of a pin and drag from the end of a pin. So that means we want to draw a signal. So we just drag it up to here, and then we let go of the mouse, and there's that signal created. Now if I go down here and click on the end of this pin and drag up to that point, the two are connected. And I want to actually connect the B there as well, so I'll just drag up to there. Now anytime that there's two signals crossing and they're connected, there will be a blob drawn to indicate that. I can always see the entire signal by clicking on it, and the whole thing turns yellow. Okay, now what I want to do now is put down a few other devices, and they're going to be coming out of Simulation IO. And Simulation IO, they're really pseudo devices. They're devices that bring simulation results out onto the schematic, or allow a user to put in simulation stimulus. Anyway, let's grab one of these binary switches here, and we'll place it on the clear. There we go. Now, the interesting thing about a switch is if you click on it, it changes state. So then how do you move it? Well, you hold down the shift key and click and drag. So there you go. Now, I really didn't want to do that, so I'm going to undo that operation. I can go up here and do undo, or I could just hit Control Z. Now, the next device I want is a clock. So I'll double click on the clock right below the binary switch, and I'll place it here. Terminate placement mode, and then click and drag. There you go. So we've got our simple little circuit built, and it's actually simulating, but we can't see any of the results. So what I'm going to do now is go into naming mode. In this case, I'm going to name some signals. So if I double click on that, once I come in back, the cursor, or the normal mouse cursor, is replaced by a pencil. So if I come down here and click and release, I can then type in a name like clock, CLK, and hit enter. Now immediately we'll see the clock signal appearing in the timing window. Now I also want to name this guy. Now if I don't want to actually have the default location for the name, I can click on it and then just keep the mouse down and then let it up where I want the value, the name to appear. So I'll type in feedback, which you can't see. There we go. I'll scroll up a little bit now. Now it turns out I actually do want it down there, so I can just click and drag it down to here. There we go. I just thought I'd show you that particular feature. And feedback's here, but it's pretty much stuck on a high value, and that's because the switch here is at 0, and we're in the clear mode. If we click on this, we'll then see a change, and now feedback actually has a real value. Okay, now if we want to actually interact with the simulator, we can do that by working with these buttons up here. So for example, if I want to stop the simulator, I can just click on the little man sitting down, and if I want him to go full speed, I click on the little man running, and if I want somewhere in between, I just drag it, and that'll adjust the speed of the simulator. Now if we want to change the resolution of the timing window down here, we can do that by clicking on these buttons, and if we zoom out, they'll get a lot smaller and we can see a lot more data. If we want to zoom in so we get more detail, we click here and it keeps getting bigger. And if we want to return back to normal resolution, we just click here. Now, one other thing I forgot to mention about the simulation speed is you can actually stop the simulator and then single step it if you wanted to, by just repeatedly clicking on the man standing. So let's return it back to full speed. I'm going to do a little bit more naming now, so I'll just grab the naming tool, and I'm going to go here and call that D7, and call this D6, and they start appearing in the timing window down below. Now we can also modify the parameters of a particular device. So for let's highlight this. We can go up here and go simulation parameters, and we can change the delay through that device. So we can use the arrows here, or if we want, we can just type in a value. And that changes the delay through the device and would therefore have a change in the timing information down here. Now there's other ways of seeing simulation values other than just the timing waveform down here. You can also do it by putting down what we call probes, and there's a device called a binary probe, which is right above the binary switch. We double click on it and we go along and we place it here, and it'll show us the value as it changes on that particular signal. And we can do one, say, here as well, briefly, and it's just going up and down to beat the band. So I'm going to remove those. I can do that by just clicking on it and hitting the delete key, or I can get rid of it by using this lightning bolt. Now, in addition to those probes, sometimes you only want to see the value momentarily. You don't want to actually lay the probe down and have to delete it. You can actually use the signal probe tool. You click on this guy up here, and as you come down you'll see a little question mark and a little pin sticking out the bottom, and you can just hold it down on a particular signal. Now and it'll show you the value. So if I go over here and hold it down, it shows me a 1 because that's what the switch is set at. If I over the clock here and I click on it and hold it down, it shows me the value as it's changing. So that's a very quick way of seeing the value of a particular signal. Another way is to go to the simulation and say show values, and as you see here it puts out the values of all the signals and you can look at them. Sometimes that can be useful, and other times it just clogs up the diagram. So again, it really depends on your preferences and what you want to do. So I'll turn that off. I find it a little distracting when there's too many of them being displayed. Okay, that's probably enough for the first tutorial. Now what we'll do is save the design. So we go up to File and Save Circuit As, and we'll type in a name. We'll call it Video 1. Or actually, I think we'll call it Part 1. There we go when we hit Save. Okay, that's it for video number 1. Do come back and see video 2 and 3 and such. So thank you very much and have a good day.